Hi everyone. Today we are going to study cohesion. Now what is cohesion? Cohesion basically refers to the degree to which elements within a module work together to fulfill a single well-defined purpose. So here we are talking of a single module and how within a single module different functionalities are achieved for a well defined purpose. So how different elements are working together in the same module to fulfill a single well defined purpose. Now high cohesion means that elements are closely related and focused on a single purpose. So if the cohesion is high, that means all the elements are very closely related. High cohesion means close relation among the elements, and they are closely related and focused on, of course, a single purpose. While when we talk of low cohesion, it means that elements are loosely related, they are not much highly related, and of course they also serve multiple purposes. So in high cohesion, the elements are closely related and serve a single purpose, whereas in low cohesion elements are loosely related and serve multiple purposes. Now talking of types of cohesion, we have various types of cohesions, among which the first one is your functional cohesion. So the functional cohesion, every essential element for a single computation is contained in the component. So if for a single computation, that means one function, all the essential elements that are required for that single computation, they are contained in that particular module or component. A functional cohesion performs the task and functions, and it is an ideal situation. So basically when we talk of functional cohesion, that means performing tasks and functions to achieve certain functionality, and this is considered the ideal form of cohesion. The second type of cohesion is sequential cohesion. And in sequential cohesion, an element outputs some data that becomes the input for other element. So how are the elements related in sequential cohesion? That one element produces some output which in turn becomes the input for the other element, and this happens naturally in functional programming languages. So whenever we do use any functional programming languages, sequential cohesion happens by default or naturally. Third kind of cohesion is the communicational cohesion. In communicational cohesion, two elements operate on the same input data. So basically there is only one set of input data which is being operated upon by two elements. That means more than one element, or they contribute towards the same output data. So basically whether it is an input data or it is an output data, more than one element, that means two elements are operating on either the same input data or they are contributing towards the same output data. As an example, when we update records in the database and send it to the printer, so that means the same records are being operated upon by both the database and the printer. So two elements, data and database and printer, contributing towards the same output data, or working upon the same input data. The fourth kind of cohesion is procedural cohesion. In procedural cohesion, elements of procedural cohesion ensure the order of execution. So basically here the name itself is procedural cohesion, that is the order of execution is of priority over here. So all the elements in procedural cohesion ensure that there is a certain order of execution. Actions are still weakly connected and unlikely to be reusable. For example, if when we calculate student GPA or print student record, or calculate cumulative GPA or print cumulative GPA, so that means there will be an order of execution for that, because you cannot print the student record unless you calculate the student GPA. So first of all the student GPA will be calculated, then the student record will be printed. So that means it focuses or it ensures the order of execution, but actions are weakly connected, unlikely to be reusable. The fifth kind of cohesion is your temporal cohesion, wherein the elements are related by their timing involved. That is why the name temporal, that means related to timing. So how are the elements related in this kind of cohesion? By their timing. In a module connected with temporal cohesion, all tasks must be executed in the same time span. That means whatever tasks are there in a particular module, they all must be executed in the same time span. And this kind of cohesion contains the code for initializing all parts of the system. So when it comes to initializing all parts of the system, this temporal cohesion contains that kind of a code wherein all the tasks are executed in the same time span. Lots of different activities occur all at one unit time in temporal cohesion. The sixth kind of cohesion is your logical cohesion, wherein elements are logically related and not functionally. So how are elements related? Not by the functionality that they perform, but logically. For example, a component reads input from tape, disk and network. So this exhibits logical relation but not functional relation. All the code for these functions is in the same component. So whether it is reading input from the tape or disk or network, all the code for these three functions is in the same component or the same module. Operations are related but the functions are significantly different. Operations are related, like the read operation is being performed whether you are reading from the tape or from the disk or from the network, but functions are different. One function is reading from the tape, another function is reading from the disk, and the third function is reading from the network. The seventh kind of cohesion is your coincidental cohesion. In coincidental cohesion, the elements are not related, right? So here the elements are not related, rather they are unrelated. The elements have no conceptual relationship other than location in the source code. It is accidental and worst form of cohesion. So the worst form of cohesion is your coincidental cohesion, and the ideal form of cohesion, as we studied, was the functional cohesion. For coincidental cohesion, the best example is that when you print next line and reverse the characters of a string in a single component, that you can consider as an example of coincidental cohesion. The eighth kind of cohesion is procedural cohesion. This type of cohesion occurs when elements or tasks are grouped together in a module based on their sequence of execution. That is, depending on what the sequence of execution is, the elements would be, or the task would be, grouped in a module, such as module that performs a set of related procedures in a specific order. So procedural cohesion can be found in structured programming language. The other kind of cohesion is your communicational cohesion. In communicational cohesion, it occurs when elements or tasks are grouped together in a module based on their interactions. So the name itself says communicational cohesion. So that means how would the elements or tasks be grouped in a module? Of course, based on their communication or interaction with each other, such as a module that handles all interactions with each other, such as a module that is handling all interactions with each other with a specific external system or module. And this type of cohesion can be found in object-oriented programming languages through objects and classes. Then is your informational cohesion. Informational cohesion occurs when elements or tasks are grouped together on a module based on what? Based on their relationship to a specific data structure or object. So here the relationship is based on what? The data structure or object, such as a module that operates on a specific data type or object. Informational cohesion is commonly used again in object-oriented programming languages because the tasks are grouped according to the data structure or object. Then we have functional cohesion. The name itself says functional cohesion. That means in this type of cohesion, elements or tasks in a module contribute to a single well-defined function or purpose. That means all the elements would be contributing to a same or single function or purpose, and there is little or no coupling between the elements. So this is functional cohesion. Functional cohesion is considered the most desirable, as I said. Then comes your layer cohesion. Layer cohesion occurs when elements or tasks in a module are grouped together based on their level of abstraction or responsibility. So whatever the level of abstraction or responsibility is, that elements are grouped together accordingly, according to that in the layered cohesion. For example, a module that handles only high level business logic, or a module that handles only low level business logic. Layer cohesion is commonly used in large scale software systems to organize the code into manageable layers. So this is all about cohesion.